Hi, let's get ready for Chapter 8. In Chapter 7, you learned all about square roots and cube roots and stuff. Well, Chapter 8, we're going to start using them a little bit more, and also squares of other types, and cubes of other types. Let's get started. Let's talk about area. I'm going to move my area over here. Area is the amount of space an object takes up. Area is the green stuff here. The area of that rectangle is the green space that is created by that rectangle. Okay, if I wanted to find the area, in most of these problems, it involves me taking a base or a height, multiplying them together, and in some other cases, I have to do just a little bit more. Now, are we going to do area a lot in this chapter? No, we're going to do what's called volume. Am I talking about volume like turning things up and turning things down sound-wise? No, I'm talking about a different concept, and you will learn. But what we need to do right now is understand area before we can understand volume. If I were to find like the area of an object in feet or in inches, I'm not going to say, well, that answers in 5 feet. That area is 6 inches. No, you would say inches squared, feet squared, units squared. So here's our area formulas. I remember them. Let's see if you remember them as we move on. You're not going to have to memorize them, but you probably already have the rectangle. And if you know the rectangle, the parallelogram is literally the exact same thing. Triangle is literally the exact same thing. You just multiply a half to it. And trapezoid is almost literally the exact same thing as a triangle. So let's do a few. Let's do 4 of them. Let's do an example of each. Let's start out with a triangle. I have to find the area. The area of a triangle is 1/2 times base times height. My base is 5. My height is 3. Everything in centimeters. So my area is going to be 1/2 times base, which is 5, times height, which is 3. Any questions? Half of 5 is 2.5. Half of 5 is 2.5. And 2.5 times 3 is 7.5. My area is 7.5. 7.5 what though? Centimeters squared. Remember, the area is measured in units squared. So my area in this case is 7.5 centimeters squared. All I did is I took the information that I had, I plugged it into the formula, I did some math, and bada bing, bada bang, bada boom, you're done. What's this thing? A rectangle? How do I find the area of a rectangle? Length times width, base times height, whatever you want to do. A lot of people prefer length times width, a lot of people prefer base times height. Either way, you're just multiplying 4 and 3. So A is going to be 4 times 3, which is 12. 12 what? 12 meters squared, because I'm finding the area. A parallelogram. Well, if you remember, the area of a parallelogram is base times height. And if you're like, but why is it the same? If I were to take that chunk right there and move that same exact chunk into that area right there and just pretend that the triangle that I had on the left is not there anymore, I end up with a rectangle. So it's the same exact thing. You're just moving stuff. Move it. The base is 12, it says it. The height is 5, it says it. 12 times 5 is 60. My unit of measure is centimeters, so my area is 60 centimeters squared. Okay. So far, not bad. You get the formula and you plug it in. Well, here's the formula for parallelogram. You have 1/2 times A plus B times H. What's the A, what's the B, and what's an H? The A could be either the top or the bottom. It doesn't matter. The b could be the other one that you didn't choose, and a lot of people would probably use b for the bottom because b is for bottom. Bottom. Oh, we'll call you h. Okay. So let's plug in what we know. A is 1/2 7.2 plus 13.4 times 10.6. PEMDAS says do everything inside the parentheses first. 7.2 plus 13.4 is 20.6. It's supposed to be a parentheses. I'm lagging here. If I multiply these three together, because I'm running out of space here, so I'm just going to multiply all three of them together right now. I'll get a little over 100. Let's use the calculator to find out. 1/2 times 20.6 times 10.6.
It's 109.18.
109.18. 109.18 what? Meters squared. Yeah. That'll do just fine. Okay. We'll switch gears. In what number, or in between what two integers does the square root lie? I don't know what the square root of 72 is, but you know what I do know? What the square root of 64 is, and I know what the square root of 81 is. The square root of 64 is 8. The square root of 81 is 9. Now, why did I choose those guys? I don't know what the square root of 72 is, but I do know what my perfect squares are from the last chapter. My perfect squares are 1, 4, 9, 16, 25, so on and so forth. I know that if I were to take the square root of a perfect square, I get a nice integer like that. And that's what I want. I want two integers. I don't know what the square root of 72 is, but I know that 72 lives in between the perfect squares 64 and 81. So the square root of 72 is going to live in between the square root of 64 and the square root of 81, which is 8 and 9. Okay. Do I know what the square root of 18 is? No. But the square root of 18 lives in between the perfect squares 16 and 25. The square root of 16 is 4. The square root of 25 is 5. So the square root of 18 lives in between 4 and 5. It's going to be 4 point something. 4 point, I don't know. Speaking of I don't know what the square root of 54 is. But I do know what the square root of 49 is. And I do know what the square root of 64 is. And 54 lives in between those two numbers. So my answer is going to live in between these two numbers. No calculator, baby. It doesn't even want a calculator. Calculators are for sissies. So let's bring back Pythagorean Theorem, which is what we did in Chapter 7. Okay, so in order for us to really do well in Chapter 8, we're going to understand a lot of what we did in Chapter 7. Makes sense. These are right triangles. What do I do when I have to find the missing side of a right triangle? Pythagorean Theorem, of course. There he is. There's our old friend. Now, when I label my triangle, I have to make sure that my longest side is always C. It doesn't matter what your other two sides are as long as the longest side is C. So I write out my formula. A squared plus B squared equals C squared. According to what I labeled, A is 6, so 6 squared. B is 8. I almost caught myself. Squared. And X is C squared. 6 squared is 36. 8 squared is 64. Let's move it up here. Change colors. 36 plus 64 is 100. Is X all by itself? No. What's in the way? Squared. How do I get rid of squared? Square root it. Square root it. X equals 10. What's my unit? I don't have one, so I'm going to leave it blank. You could say units, but since I don't have feet or inches or whatever, I don't have to do it. One more to go. I have a right triangle right there. I don't know that guy right there, but I do have to make sure I call 12C because it's the longest side. I can call 8A, I can call y b, and I can write out my equation. A squared plus b squared equals c squared, where a is 8, so 8 squared. Y is b, so y squared, and that's going to equal c squared, which is 12 squared. 8 squared is 64. Y squared is, I don't know. 12 squared is 144. Is y all by itself? No. What's in the way? 64 first, so let's get rid of it. Let's subtract 64 from both sides. Y squared equals 80. Is y all by itself? No. What's in the way? Square root it. What's the square root of 80? I don't know. I do know that the square root of 81 is 9, so this guy's going to be a little bit smaller than 9, so let's find out. Square root of 80?
The square root of 80 is approximately 8.94427.
So we'll say 8.94. And that's that. Bye!